So proportional reasoning, again, we got today and lesson 8 tomorrow. Then we'll be wrapped up with unit 8. First question says, for each pair of values, build the simplest mobile possible. So there are some different possibilities. We're just building the simplest one possible to come up with it. So the first one there, it says each side is 6.
12.
That means obviously a total of 12. And now we have to build it. Simplest way is probably to put 2 squares or 3 squares on the left. Triangles are 3, put 2 of them on the right. That's probably the simplest we can get. Second one, if the left side is 4, that of course means the right side is 4 for a total of 8. Simplest way to represent each side.
4 triangles and
Yeah, 4 triangles and 1 square. Pretty simple. Next one doesn't tell us anything. So what is a nice number that we could put on there?
9.
9. 3 triangles. 9 squares. Next one, looks like they're worth 3 and 5. Kira, what's a good number that we can go to?
15.
How many squares?
5.
Or 3 triangles. Now we're on page 35. Please join us. Thinking out loud, it says Michael, Lena, and Jay discuss their approach to this problem. It takes Damien 2 hours to get 5 gardens watered. Write an equation that relates to that. Michael says if h is the number of hours, we can say that h equals 2. Lena says, you're right, Michael. For a second, I was thinking that 2 hours means we have 2 h's, but that's something different. Since h is a number of hours, 2h means doubling the number of hours, which we aren't doing anyway. So yes, I agree that h equals 2. Number of gardens, which is g, equals 5. So how are h and g related? Michael says. Let's try some numbers first. If you can water 5 gardens in 2 hours, then watering more gardens should take more time. Like 10 gardens should take 4 hours. 15 gardens would take 6, and so on. How do we turn that into an equation? Jay says 5 and 2, 10 and 4, 15 and 6. We could write those as fractions. Those are equivalent fractions. Michael says that's a lot of equal signs. Also, the equation is supposed to relate h and g. Lena says in all those fractions, the numerators are all values of g, the denominators are all values of h. So that's the pattern, so they add g over h to the fractions there. Michael says that looks way too complicated. The first 3 fractions are all equivalent, so we don't need to compare g and h to all 3 of them. He said, here's a simpler one, and he just compares it to each individual fraction. What if we had written the fractions the other way? He thought, 2 hours per 5 gardens. I'd write the fraction of 2 over 5. And he says, does h over g equal 2 over 5 also work? Or Jay says, what if we don't use fractions at all, which is what we're going to get into today? The equation would be 5h equals 2g. Now, why is that? Well, what's 5 times 2?
10.
And 2 times 5?
10.
Yeah, so they are equal on both sides. So just make them both sides equal. Next page. First thing we're going to do is just talk about equivalent fractions. So equivalent fractions for the first one. 33 over 44. Give me an equivalent fraction to that one. Something that could reduce or get bigger, I guess, but it'd be easier to reduce.
22 as a denominator, and
Yeah, they're going to have a decimal on top then.
yeah,
How about if we divide by 11?
3 over 4.
3 over 4.
3 and 4.
Yep. And you could have taken them times 2 and wrote 66 over 88 and so on. 3.
9 and 6.
Divide by 2? Sure.
36 and 24.
Double them? Sure. Question 4. This one you can't really reduce, so how about we double the top and bottom?
4A and 10.
There you go. 5. This one you could reduce or double.
1 and 4.
1 over 4x. Perfect. Divided them both by 2. All right, determine the missing value of these equations by thinking of equivalent fractions. So again, I like to write the arrows in here. 7 times 4 is 28. What's 3 times 4? 12. Okay, why don't you try the next 3, see if you can find the missing variable. All right, Kira, got any of them? 7, 8, or 9?
9.
Okay, how'd you draw the arrow?
I drew it. It's going to the left.
Going to the left? So how did I get from 42 to 7?
Times 6.
That'd be divided by 6 if you drew it left.
Divided by 6.
So 36 divided by 6?
6.
Yes.
Could you also do 7 to 36 for 4?
7 to 36 for 4. I don't understand.
Oh wait, I did not know. Ignore me.
7 times 6 is 42, so 6 times 6. You have to get to 6.
Yeah.
Maddie?
7.
Okay, which way did you go?
3 to 27.
Times 9?
Yeah.
8 times 9?
17.
Yep. Devin, you got 8?
No.
Landon?
No, I didn't click it. Actually, but I can figure it out. Though.
Okay, let's hear it.
So I do 9 times, I do 54 divided by 9, and 54 divided by 9 is 6. So then I divide it by 6. So then 48 divided by 6 is 8.
Yes. All right, question 10. Asher is selling carnations. Makes a bouquet of different sizes using 4 white and 3 pink. So I'm going to use the little note here that W is 4. P is 3 for the number of carnations. Write an equation for the relationship
P equals W minus
between W, number of pink carnations, and white carnations. So they recommended, as we did that talk about it or whatever it was right away, we're going to write it as W over P. Okay, that's white to pink, kind of like a ratio. So white to pink is 4 to 3. So there's one equation you could write.
What about,
You could have it flipped over.
Oh, yeah,
P over W is 3 over 4. That would be fine. Some people like to cross multiply and write 3W equals 4P. That would be fine as well.
And then you could do it the other way and do 3P equals 3W.
Can't have 3P.
Or, I meant 4P equals 3W.
Yes, that could work as well. You could also double both of them and so on.
So what if I did 9 and 16? Would that work?
Yes.
Oh, I suppose it's doubling.
Well, no. If you get 9, that'd be 12. If you take it times 3 to get 9, you got to take 4 times 3. So it'd be 9 and 12. All right. So B. How many pink carnations are in a bouquet with 20 whites? So let's go white to pink. That's what I have here is 4 to 3. How many whites? No, how many pinks can you get for 20 whites? How many pinks can you get for 20 whites? If it's keeping in that same ratio.
5.
No.
5
Is more than 5. I mean, this is times 5 if that's what you're referring to.
Yeah.
But that does not tell me that my answer is 5.
15.
15 pink carnations. How many whites can you get with 24 pink? So again, I'm going to start with white over pink is 4 over 3. 24 pink, that would have to go on the bottom because that's where the number of pink carnations is. And what is W then?
If you take a
Times what?
6.
Nope.
What?
Times 8.
Oh, times 8.
3 times 8 is 24, so 4 times 8.
Oh, I suppose you.
What'd you say?
4 times 8.
28.
32.
30.
I think we better get out that little chart, guys. We should know 8 times 4. If not, use a chart. We can try number 11. We'll skip 12.
Oh, that's
2 things that multiply together to give you a blue. So whatever the blue is going to be the same.
Can you try this on our own and see what we get in the end?
Sure. Divide both of them and get a yellow. I'll try an easy one first. Nope.
What? Oh,
Nope. Oh, I see it now. So I tried 1 and 1, and then 1 and 2 didn't work because that would have been a half then. half plus a half wasn't 1. So once you see enough of those, you get a pattern down. Not too bad. All right, question 13. That's what we did again today. 2 books in 7 days. So books and days. I'm going to use B and D to represent that, obviously. Write an equation. All right, books over days is 2 over 7. There's my equation. Again, you could have it flipped. Both of them would have to be flipped then. Could cross multiply with a proportion and have 7b equals 2d. A lot of different options you can have. Question B, how many books can you read in 70 days? So books to days. 2 books in 7 days. How many books in 70 days?
10 books.
How many?
10.
No.
20.
Okay. Sure.
20.
20? It's times 10. I think that's what you're referring to, Devin.
Yeah.
2 times 10 is 20. Books. Question C, how many days would it take him to read 12 books? So books is on top. So the 12, because it's books, also has to go on top.
Times 6.
Answer?
42.
7 times 6 is 42 days. Yep. How many books can he read in 316 days? Don't calculate this, just write an expression. All right, books over days is 2 over 7. Does 316 go on top or bottom? Bottom. It is days. Days is on the bottom. There's our expression. Again, it doesn't say to calculate it. How many books can you read in D days? Books to days. D days on the bottom. How many books? We can probably simplify this one a little bit more. 7 times B is 7B. 2 times D. How do I get D by itself?
Subtract.
Nope.
What divide?
Divide by 2. So D would equal 7B over 2. It's times 7 divided by 2. All right, next page. Why don't you try number 14? That's everything we've worked on so far. Got 3 different relationships, so make sure you're paying attention to what it's telling you in the problem. You can just use C, F, and B.
If C is greater than F, do we put C at the bottom?
All right, so this one's talking about cookies and flour. So I would just write that.
Okay.
Now you could reduce it and go 16 over 1. You know, we talked about that at the beginning of the lesson. A lot of different options. What's that? That's fine. Then you're going to have 3 over 48. Next one wants a cup of flour and sticks of butter. So that's F over C. Be 3 over 2. Again, could have that one flipped as well. I guess I use B for butter, not C.
I get the 2 bottom ones.
All right, only one stick of butter in the house. How many cookies can he make? Cookies to flour.
24.
Nope, cookies to butter. 48 cookies. 2 sticks of butter. How many cookies can he make with 1 stick of butter? Yep, divide by 2. 24 cookies.
20.
Half of 48. All right, there's the second part there. How much flour will I use?
24 is half 48, isn't it? Or did I just read it?
All right, so 48 cookies over 3 cups of flour. How much flour will I need for? You just told me I'm making 24 cookies. How much flour? No. I'm making less cookies. How would I have more flour?
6.
That's still more flour. I'm making less cookies. You just told me I'm going from 48 to 24.
2.5 or 1.5.
Yeah, half of 3. 1.5 cups of flour.
A lot of flour.
All right, next one. I got 2 cups of flour. Flour's over cookies. I got 48. Nope. I got 3 cups of flour. We'll make 48 cookies. 2 cups of flour will make how many cookies? Obviously going to be less than 48. I think 3 times 16 is 48, so 2 times 16. 32 cookies. How much butter? Well, 2 cups of butter made 48 cookies. How much butter for 32 cookies? Looks like divided by 24, so 32 divided by 24. Let's reduce that. 8 goes in there, I think. 32 divided by 8. 4. 24 divided by 8. 3.
6. Wait, what?
24 divided by 8. Use your charts.
Oh, I was thinking.
4/3 of a stick of butter, or 1 1/3 would be fine as well. All right, I think we've done enough of 15, 16, and 17s. Try number 21.
It's so funny.
21.
Isn't the Kayla traveling to North Carolina?
Good. Thank you. Click out of it now. Page is that on?
37.
37 on page 37. All right, can't get much more than a real life situation here. 20 miles per hour. That means you go 20 miles in 1 hour. So how far can you go in a half hour?
10 miles per hour.
You agree with that?
Yeah.
Why?
Because that's half.
That's half, yep. 10 miles. Okay, well, what about now 15 minutes?
5 miles.
Yeah, half of what you just had before. 2 hours?
40 because it's double.
Good. Number 22. Ben rides a bike 5 miles in a half hour. Devin, how far can you go in miles per hour?
You can go.
Maddie?
10 miles.
Double. 23. If Kayla walks a mile in 15 minutes, okay? You walk a mile. Put yourself in these shoes, literally. Walk a mile in 15 minutes. How far can you go in miles per hour? How fast are you going?
Miles per hour.
What's that?
4 miles per hour.
4 miles per hour. Because 15 minutes times 4 is an hour.
Congratulations.
Thank you.
Okay, it took Ben 3 hours to drive 99 miles. How fast is he driving?
33 miles an hour.
Miles divided by hours is 33 miles
Some slow driving.
per hour.
What's faster than we drive in town?
But not for
What
me.
you're allowed to drive.
Not from my sister, no. She drives like 40.
All right, page 38. Which one? Let's do 26.
They don't put you in prison for speeding, Landon. They
What?
fine you.
Well, you can be put.
Landon, anything we know about 26 off the top of your head?
Well, obviously 2 goes in the middle.
Obviously, 2 goes in the middle. How about the bottom left? 2 numbers that multiply together to give you 1. And they can't both be 1 because they're right next to each other. 2 and what?
2 and 1/2.
2 and a half. So 2 has to go there.
Oh,
Half next to it. So what goes above that?
1 and 1/2. And then beside it goes
1.
1.
All right, multiply together here to give you a half.
Give a half.
Multiply together to give you a half.
1 and 1/2.
1 and a half. So 1 has to go here. Half here. Landon, top right.
2.
Next to it
1.5.
and below it.
1.
Good.
Maddie said that was too easy, and I said it's because you started.
29. Raj read about a glacier that is moving west at 75 meters every 2 years. How far will it move in 1 year? Devin, you with us? Go 75 meters in 2 years.
75 divided by 2.
Half of 75, what is that?
50.
50?
40.
I'm thinking by quarters.
48 or 46.
48. 46, 8, 9, 10.
That'd be half of 90.
75 divided by 2.
Isn't it 37.5?
37 and a half.
Good job.
Man, that calculator knows how to do math.
I know, right?
B, how far does it move in 20 years? How would we get that?
Times 10, 750 meters.
What's that?
Times 10, 750
Times 10.
meters.
10 years longer, 10 meters further. Times 10.
That's a lot of meters.
So much.
Question C, how far does it move in 423 years? Don't calculate it, just write how you would find it. Go ahead.
I'd like to argue that it wouldn't be here in 423 years.
It's not asking about you, it's asking about the glacier.
Well, it would
Plus,
be
if
like-
you only move 75 meters in 2
But
years, you probably
gotta
should
think of it.
take a look at your life and see why you're only moving
What if there's a land?
75 meters.
Yeah.
You gotta think scientifically. What if there's land in front of that?
That glacier's just gonna mow right over the top of any land.
It does.
Global warming.
It's a real issue.
How far does it make in 1 year?
Exactly.
I said in 1 year, 37.
Yep, so I got to take 37 and a half
Times.
times 423.
Yeah.
I use calculator.
It says not to calculate it. How far does it move in t years? So again, you'd take 37 and a half times t. They use t because it can vary. That's why it's called a variable
It's not
to get our answer. So however many years you want to figure out, take it times 37 and a half. Last question
I thought they called
of this part.
it variable because it's variable.
Which of these following equations would help you find it?
I need number one. That's what I meant. No, yeah.
Don't know how to read ramen noodles.
I don't. I think they're ramen noodles. I've never.
What do you think?
I haven't been.
Mel thinks A, I believe, for the first one.
That's not A,
I
that's
say
one.
second one.
Second one?
Well, why are you subtracting? Why would you subtract the half?
My problem is we've never done
Divide
2
it by
over
half.
2 divided by 75 on any of this.
Did we just did it. It was like 36 or something.
That's 75 divided by 2.
3.
Half?
I say two. I'm
We've done this one, 37 divided by 2.
3.
4.
Oh.
It's the last one.
Yay.
Yeah.
Distance equals rate times time, so 37 and a half times t. Times t.
What?
All right, number 30, last one we're going to discuss. Obviously 16 on each side to give us 32. Now let's look at the right side.
Butterflies are 2.
These would both have to be 8.
Nice.
And then 4.
These would both have to be
Butterflies are
4.
Butterflies are 9.
Butterflies are not 9.
Gross at butterfly.
Butterflies are 2.
I was saying it as a joke.
Some jokes just.
All right, what is 16
Calm down, you two.
minus 2?
2 minus 2 is 14.
14, so each one of these will be 7.
Oh, what?
Yes.
4 and 3.5 are the circles.
So circles would have to be 7 over 2 or 3.5 to get to 7.
That'd be 3.5.
And the triangles,
Half.
half
Go team.
Ooh.
or 0.5.
I'm so proud of
We're
us.
awesome. Oh, for sure.
Genius.
Just be happy.
All right, your assignment then is page 39.
I'm always happy.
Landon,
Yeah.
G or H, I will let you get rid of one of them.
Iron, holy! We are gonna do cha-cha-cha. We are gonna probably get rid of G. Why G? That's like the hardest one.
Oh my word.
That's the point.
Come on, Landon.
Oh, we're gonna get rid of H.
We're gonna get rid of H.
He knew what you were doing.
There you go. Do all of them but that one.
No,